Okay, so what we're looking at here is a set of notes on inequalities in two triangles. Last time around we looked at inequalities in one triangle. So here we're going to kind of just slightly advance that a little bit into a case where we have more than one triangle. Okay, so the basic theorem in this is what we're going to call the hinge theorem. Essentially, if I have one triangle, then we'll call this one A, B, C, and I have a second triangle. Let's make this more clear. Call this one D, E, F, and AB is congruent to DE, and BC is congruent to EF, and the measure of angle B is bigger than the measure of angle E, then the idea here is that this is going to imply that AC is also going to be bigger than DF. Okay, so there's a whole big long proof for this in the notes there. I am not going to walk through that in the video. It's somewhat unnecessary and a little bit confusing, so I'm not going to cloud the matter. But if you can kind of think of this, this is like the hinge of a door, and if I have the door opened a little bit, then the gap in the door is small. If I have the door open a lot, then the gap of the door is big. So when the angle is bigger between the two sets of congruent sides, the included angle is bigger, then the space that is in the opening must also be bigger. Okay, so there's also a converse to this, and the converse to the hinge theorem does in fact hold. So in the converse to the hinge theorem, I have a situation where I have two triangles. And again, this is congruent to this. This one is congruent to this one. We're going to label these like QPR, and we'll label this one YXZ, and we'll be given that QR is in fact larger than YZ. So the converse of this theorem says that if that's true, then the measure of angle P has to be bigger than the measure of angle X. Okay, so what we're going to do is we're going to prove this by contradiction. We're going to assume that that's false. So we're going to assume that the measure of angle P is not bigger than the measure of angle X. So this implies one of two things. Either the measure of angle P is smaller than the measure of angle X, or the measure of angle P is equal to the measure of angle X. Well, if it's smaller, then according to the hinge theorem, QR has to be less than YZ, which is a contradiction of our given, that QR is greater than YZ. So that can't possibly be true. Okay, so the other option is that they're equal, but if these are in fact equal, then these two triangles would be congruent by SAS, side angle side, side angle side, which means that QR would have to be equal to YZ by CPCTC, which again contradicts my given, because in the given QR has to be greater than YZ. So this cannot be true, this cannot be true, which means the assumption is not true. And the assumption was that this is the opposite of this, which means ding ding, this has to be true. All right, so the hinge theorem says that the triangle that has the bigger angle has the bigger gap. The converse to the hinge theorem says that the triangle with the bigger gap has to have the bigger angle. All right, so there you go, inequalities in two triangles.